Morning, guys. Well, we're down to 2. This is our second last lesson for the whole course. Don't get too crazy on me now. The topic that we're going to cover today is Poisson Distribution. Now, let's think about what we've covered so far. We've covered expected value. We've covered, which is a binomial or a probability distribution type of question. We've covered Bernoulli, which is a probability distribution with 2 outcomes. We've covered geometric distributions or waiting times, which also have 2 outcomes. We've covered normal approximation to the binomial distribution, again, 2 outcome questions. And now we're going to look at Poisson distributions. And when you take your stats course in universities, there's multiple different types of distributions. This is just, the start of the different types of distributions that you can work on, okay? All right. It says, in probability theory and stats, the Poisson distribution is a discrete probability distribution that expresses the probability of a given number of events occurring in a fixed period of time or space if these events occur with a known average and independent of the time since the last event. So I know that sounds like a lot. I get it. But the key to this, which is so different than our other questions, is that there will be a time element to every single one of these questions. Okay, now hold on. The other difference is that you will be given an average rate, which is very different than the others. Okay, so what types of questions are we talking about? What is this fixed period of time? What is this discrete probability? What is this known average business? What type of events are we talking about? What type of events follow a Poisson distribution? Number of telephone calls per day. Number of texts or email per day, per minute. For some of you, per second. Number of car accidents per month. Number of points per game. Number of customers coming into a store per hour. Number of deaths per year. So notice the key word that's in every one of those sentences, and the key word is per. There's a time element per year, per month, per day, per game, per minute. Okay? Now, completely different formula. So let's take a look at it. Kind of weird. Probability of the number of occurrences. Okay. X bar. Sorry, guys. X bar, which is our average, raised to the X, which is the number of occurrences, times E. Now, E is very much like what we would know pi, okay? When I say pi, everyone out there thinks 3.14. When I say E, it's a constant, and it's approximately 2.71828, okay? And you'll notice there'll be an E button on your calculator. I'll show you that in a second. So the average to the number of occurrences times E to the negative number, that should be X bar again, to the negative average, all divided by the number of occurrences factorial. Okay, let's just go over that one more time because it's just so obscure and I had to put the X bar in a couple times. Average to the number of occurrences. E, which is a constant, similar to pi. It's not the same value as pi, but it's a constant, to the negative average, all divided by the number of occurrences with our factorial symbol. Okay, I'm not going to argue with you. The formula is bizarre. Okay, but it's easy. We're going to work our calculator and get things going here. Okay, what I wanted to do is I wanted to show you my calculator for a second, just before we flip. And you'll notice the log button, which my functions kids have seen before. And log is base 10, okay? Beside the log button, and you'll have to look around on your calculator, is a ln button, ln. Ln is base E, so you'll notice on my calculator, right above the ln button is my beautiful E button to the exponent x, and that's what I'm going to access. So take a moment, maybe turn the the doc cam off or your video off, and make sure you know where your E button is on your calculator. Okay? All right, let's flip. Again, with this type of lesson, the best way is to jump into some examples. So it says, let's look at an example. Suppose someone gets an average of 4 pieces of mail per day. So let's use the Martel household. I decide that I'm going to start tracking our mail, and I calculate that we're getting an average of 4 pieces of mail at our house per day. That's my X bar. There will be a certain spread. Sometimes, maybe around, dead times during the year, I might get a little bit less. Maybe around Christmas, I might get a little bit more. Once in a while, I might go to the mailbox and there's absolutely nothing there. Given only the average rate, and assuming that the process that produces the event flow, getting mail, is random, the Poisson distribution specifies how likely it is that you will get any number of pieces of mail on a given day. So it gives you the probability of the number of occurrence based on being given the average and the process being random. Okay. It says, what is the probability that you will get exactly 6 pieces of mail? So hold on, I just want to stop and talk for a second, because the day that you guys get the test, again, the big thing is going to be, what type of question is this? As soon as you're given an average, remember how I told you when we were doing normal approximation that as soon as you see the word between, you know that it's a normal approximation? As soon as you're given the average, Poisson. Okay, so if that's the case, I'm going to scoot over and I'm going to take a look at the Poisson formula. So probability of 6 pieces of mail exactly. And I'm just going to rewrite the formula out because, we got to take a little bit of time. X bar to the X, so the average to the number of occurrences. E to the negative X bar. E is a constant. We're going to use our calculator. All over the number of occurrences factorial. So let's fill in the numbers here for a second. X bar is 4. Average number of pieces of mail attained at the Martel household. X is the number of occurrences, the 6. E is going to be the E button to the exponent -4. negative average, all over my x factorial. Okay, now let's break up the formula here and make sure we can do everything on our calculator. 4 to the exponent 6, 4096. E to the negative 4. Second function e to the exponent negative 4. Oh, maybe I better put it in brackets. Hold on for a second. Second function e, oops, second function e to the exponent negative 4. Oh, why is that?